Hi, John Conley here, your guide to all things audio tech from the KeyCode Audio team. We've been seeing a lot of churches, performance centers, and corporate production facilities scratching their head as they consider long overdue upgrades to their live audio systems. The first questions asked is, what's changed? Well, a lot, let me tell you. It's like explaining the difference between a new smartphone and your old flip phone. We've gathered our team of audio engineers and dove deep into the latest generation of digital mixers, wireless microphones, and speakers. Digital audio mixers have become the de facto standard for any application, large or small. They offer advantages such as better signal processing, flexible routing, the ability to store and recall settings, ease of use with optional mobile apps, and they're intuitive to use. The good news, you don't need to be an audio pro to operate this gear. These newer systems can be intuitive enough for a student or volunteer to get up to speed on the basics quickly. When it comes to simplifying these systems, your familiar cable spaghetti can now be narrowed down to a few Ethernet cables. Yes, that's right, Ethernet cables. Comprehensive digital signal processing, or DSP, eliminates large amounts of external gear, thereby significantly reducing costs, as well as allowing you to achieve that warm analog sound if you'd like. Let's talk about connectivity. How does all this gear talk to each other? A term you may have heard about, audio over IP, sends multi-channel audio over an Ethernet cable. There are a few common IP-based audio protocols, Dante and AVB being the most common. A host of manufacturers support these protocols with microphones, speakers, converters, I/O expanders, basically anything in the audio ecosystem. With this technology, you can connect that 16, 32, or whatever channel stage box filled with your wired microphones, guitars, drum kits, and more to your front-of-house console on a single Ethercon cable. This reduced cabling significantly lowers installation costs while increasing routing functionality. Here's a quick example. Perhaps you're a school or a corporate campus. You could theoretically build a digital-ready podium on wheels that could be dragged from classroom to auditorium. Connect the podium to any Ethernet port on your LAN network, and now that digital mixer located halfway across the campus could still be managing the channels of audio without rewiring a thing. That leads to presets. With the move to a modern digital mixer, you can pre-configure the mixer for a variety of different use cases. Perhaps you have an auditorium that has an orchestra performing with a large amount of microphone inputs, only to be followed by a drama class that uses a mix of the same and different microphones. Within a few button pushes on the screen, you can quickly jump back and forth between these pre-configured setups. This is a huge time saver. Combining presets gets really powerful when you connect all of your audio sources over an IP network. For example, a college athletics video department could set up a preset for a stage box setup in the basketball court with another stage box on the football field. Your video control room could quickly switch back and forth between these preset sources on the network, allowing you to potentially live stream one event and then quickly move to the next. Modern mixers feature built-in DSP, or digital signal processing, allowing users to apply an endless variety of effects, EQ, and dynamics processing without the need for external gear. While incredibly powerful, these mixers can still be very easy to use. For example, digital audio mixers from the same manufacturer operate mostly the same, meaning if you start on a 12-fader Allen and Heath, learn the interface and the menu system, the layout will be mostly the same as the 36-fader D-Live mixer used for larger events. While the larger consoles will have additional processing, routing, and interconnectivity, the experience of using the layout of faders and software is a similar experience. Current touchscreen technology has come a long way. Manufacturers have made big advancements, and the result is a functional touchscreen that can be a lifesaver in many productions. For example, a modern channel EQ can now be adjusted in a fast, intuitive way, all while being overlaid on a real-time frequency analyzer. iOS and Android apps are available that allow you to mix from anywhere in your facility. It's a complete game changer. Here's a few examples. Controlling your mixer from an app means you can walk around a venue with the freedom to make adjustments to your mix from anywhere. That app can also be customized to whatever layout or function you desire. Perhaps you have a volunteer using the iPad at a town hall meeting that can just mute or unmute a microphone, and that's all it does. That volunteer doesn't need to be an audio pro and can provide a vital function at a rambunctious town hall meeting. There's a lot we didn't cover, like the expanded connectivity options that allow you to connect USB or Thunderbolt devices, automatic mixing algorithms, scene recall, simplifying complex setups, and allowing users to save and quickly switch between different configurations, or the recording of these events with seamless digital audio workstation integration. This allows for easy recording, editing, and mixing. All right, let's get into wireless microphones. When it comes to advancements in wireless microphones, it all comes down to monitoring and managing challenges, namely conflicting frequencies in an increasingly smaller frequency range. Over the last several years, the FCC has been auctioning off the wireless spectrum in the 2.5 gigahertz range where wireless microphones live. The amount of broadcast space has been halved, and wireless microphones must work within a smaller space. In addition to that, other devices such as LED walls that are growing in popularity can cause interference. Wireless audio companies are providing easy solutions with free RF scanning tools like the Shure Wireless Workbench. These apps help audio professionals assess their real-time availability of RF channels while also assessing RF environmental data. For those mission-critical productions, there's also a digital spectrum manager, which provides real-time scanning and monitors frequencies available and will use automatic frequency management to seamlessly switch between the frequencies. Digital audio, or audio over IP, has become the dominant answer to resolving the reduction of RF frequencies available. Wireless audio is transitioning from antennas to wireless routers, allowing a production to deliver more wireless sources over a network. Many advancements have been made to monitor other common issues such as wireless battery life. You can now see a countdown of battery life in real time, both at the receiver and the belt pack. This allows you to be proactive before your battery dies. Another advancement is with security. In the past, anyone could use an RF tuner to tune in and listen to your RF audio signals. This has led to some very embarrassing leaked audio moments for sure. When security matters, AES-256 encryption is now the standard. You can also take remote control of the transmitter using systems like Shure ShowLink. Advancements for harsh environments. There are a variety of microphones that are now built to withstand the harshest environments, including moisture, wind, and dust. And for those large LED walls in venues, there are shielding options designed to reduce noise. In recent years, loudspeaker systems have seen many innovations aimed at improving performance, versatility, ease of use, and reducing size. For speaker systems, the old-school heavy analog snakes required to connect mid to large-size line arrays and speaker systems are quickly getting replaced by Cat6 Ethernet cable. The most obvious benefit being the cost-reduced lightweight nature of running a single cable that can carry multiple channels of audio to patch. Open-source application layers like Milan are continuing to see advancements and picking up a lot of steam with partners like Meyer Sound, L Acoustics, and others. Built on the AVB protocol, Milan allows for delivery of control and media over an Ethernet cable. As more manufacturers continue to innovate in the network-based space, we will continue to see a reduction in the need for cabling and a simplification of controlling speaker systems in general. Speaker system design has also seen some major improvements. The weight and size of speakers have gone down considerably. This has added some flexibility to the number of speakers and subs required to fill a room, as well as things like weight loads for rigging. There's also been a significant development in acoustic simulation programs such as EASE or Map3D. These apps allow you to model and predict how speaker systems perform in your space before you buy them. They offer 3D modeling of line arrays, subarrays, digital steering columns, and conventional loudspeakers. This allows for accurate decisions on how many line arrays, speakers, and/or subs you might need. And these apps are free. Another application worth mentioning is Smart. Smart is a phenomenal tool for measuring and tuning your audio system for a room or venue. There are a host of innovations in loudspeakers, including advancements in rigging for easier and safer installs, active DSP integration, advancements in enclosure design to minimize resonance and unwanted vibrations. Reach out to Keycode for more information. This has been a high-level update of the advancements we've seen in live audio systems over the last 10 years. Hopefully, it provides a broad understanding on current audio technology. If you're currently exploring new live audio systems, reach out to the Keycode Media Audio team. We are a live audio and video reseller and systems integrator, helping with everything from designing full facilities to helping purchase the right product. Thank you for watching. I'm John Conley, Solutions Architect and part of the Keycode Media Audio team.